My name is Wenbo Ding, an associate professor at the Tsinghua Shenzhen International Graduate School. I am leading the Smart Sensing and Robotics lab.
This video is about our newest research about UltraTact, which is an integrated ultrasound augmented visual tactile sensor. Imagine holding an opaque package and wanting to know its contents without opening it. As humans, we might shake it, feel its weight, but how can robots gain this capability? Today's visual tactile sensors capture high-resolution surface information through optical imaging, but they cannot detect material properties or sense objects before contact. Recent multimodal approaches have attempted to address these limitations, but face challenges with environmental constraints, signal crosstalk, and integration complexity. UltraTact is a combination of ultrasound and tactile. It allows your fingers to not only feel surface textures, but also detect distance before touching and see inside object when it touch. We tackled the acoustic impedance mismatch challenge by incorporating hollow glass microspheres into traditional dyed membrane, optimizing the acrylic substrate thickness to a quarter wavelength, and using tungsten-loaded epoxy as backing material. The electronic system features a compact PCB with an integrated processing pipeline. Our dual-pathway algorithm dynamically adapts the ultrasound functionality based on tactile contact detection, proximity sensing before contact, and material classification upon contact. Our experiments validate UltraTact's proximity detection with high accuracy. Our superscript 2 equals 0.99 at distances of 3 to 8 centimeters, independent of target material. In material classification, UltraTact achieves 99.2% accuracy using ultrasound spectral features, perfectly classifying iron, rubber, and wood with minor confusion between acrylic and nylon. Most impressively, our dual-modal method combines texture and material sensing, reaching 92.11% accuracy on a challenging 15-class task. This greatly improves over single-modal methods. In this demo, 2 UltraTact sensors on a robotic gripper inspect 9 containers through 3 phases, approaching and grasping, touching and picking up, demonstrating robust content identification. In this video, we show how UltraTact sensors enable a robot to see beyond surfaces, detecting both external texture and internal contents of containers. By combining tactile and ultrasound data, the robot identifies each container's pattern and content in real time, even when they are randomly positioned. After sensing, it accurately sorts them into target zones. This seamless integration of multiple sensing modes showcases the robust perception capabilities of UltraTact, allowing robots to understand what's outside and inside. In conclusion, UltraTact represents a significant advancement in robotic perception through: first, a novel integrated sensor architecture combining tactile and ultrasound sensing. Second, enhanced sensing capabilities, including pre-contact awareness and internal content inspection. Third, comprehensive experimental validation in various applications. Future work will focus on sensor miniaturization, enhanced signal processing, and integration with other sensing modalities. UltraTact gives robots transparent touch, the ability to perceive beyond surfaces, opening new possibilities for manufacturing, healthcare robotics, and quality control applications. Thank you. In this experiment, the user asked the robot to clean the messy table by organizing useful items and disposing of trash in the appropriate bins. The robot should infer from touch whether the object is trash, and if so, determine which bin it should go into.
Can you help me clean up the table?
Sure. I'll go through the items one by one. This object is made of rubber. Rubber isn't usually recyclable, so it should go in the general waste bin. This object is made of metal with a flat, smooth surface. It might be some kind of container, and it still appears useful. It's not trash, so there's no need to throw it away. I'll simply place it back on the table. It is made of plastic and has a smooth, curved surface. This appears to be a plastic drink bottle. Since it is recyclable, it should be placed in the recycling bin. It's made of fabric, and it might be clothes or a towel. Since it could still be useful, I'll place it back on the table. This object is made of polyurethane foam and has a slightly rough or bumpy surface. I think it's a dish sponge, so I'll place it back neatly on the table.